Thank you, everybody, for coming to our last talk before lunch, during lunch. So we have here Martin Grund, and he's going to talk about Spark, using Spark from anywhere.
Awesome. Hey. Hello. Yeah, I know I stand between you and lunch, so I will give my best to make it worthwhile. So I'm going to talk to you about like Spark and Python and like connectivity, which is kind of weird like for a conference that is called like JupyterCon. So, but many people that use Python and like in data sciences, they always end up using Spark to a certain degree. But before we go in there, I want to ask some questions. Like, who's using Spark on a regular basis here? All right, that's some. So who is trying to debug Spark? Like a Python program. Like who loves this? Like this is like really thorough. You love debug? Well, actually, that's much more than the last time I had a room like that. 90% of people saying, "Yeah, I use Spark," and nobody likes debugging Spark applications. Because like, what the worst thing about like PySpark is? Like, I don't know how many nodes. Like embedding a JVM in a Python program. I mean, like, how bad is that? It's like Py4j and all of this. I mean, like, I don't know. Like, this gives me, I come from C++ databases, but like Python and Java in like one process. All right. So let's talk about the evolution of Spark. Because this is important to understand. Spark is kind of old, PhD project like 12 years back. No, but Spark today is associated usually with large data centers, large applications, big data processing. And over time, many people have built thousands of different apps on top of Spark and using it in any kind of different ways. However, today, these kind of data applications, like it's not just Jupyter, it's like all of these things, they don't live in a data center anymore. It's no longer just these batch jobs, but it's all kinds of things. Today, I have a bunch of developers saying, I want to use Jupyter. Then I have others saying VS Code, PyCharm, but what if I want to use Go? And again, like this kind of problem is that Spark being written in Scala, having this kind of like Python front end as well. It's like, but how do I use Go when I want to use Spark? Like, how do I make this possible? Or what if I want to use Node.js? All of these kind of problems. It's kind of hard to integrate with Spark. What if I want to use these kind of edge devices? Like, I don't know, like Google's I/O with these fancy cameras has been quite some time, but it's still worthwhile. Like augmented reality is here to stay. Data and augmented reality is definitely a thing. So how do we use all of these things together? The problem is if you zoom in Spark, all of this application logic runs exactly where the main driver and the scheduler of Spark is. So, like it's basically saying as, I want to ship my program to my MySQL database. And then I forget about it, and at some point in time I come back. And this is problematic, because when I'm doing this, like if I want to run my application from anywhere, I run into this challenge that the only way of doing this today is using SQL. But as you're all using Jupyter, for example, you like this kind of interactivity of using like the Python REPL and dealing with it. Like SQL is not really the thing, because the problem is that I'm writing some Python code, then I'm writing with some SQL, but now I need to modify the SQL, and it ends up being string manipulation. I mean, that's really bad either. So if I want to use something that doesn't run exactly where my Spark driver is, like PyCharm, like I'm kind of stuck. If I want to use languages that don't have any JVM interop, no chance. So this is where Spark Connect comes in. So when we started Spark Connect about a year ago, our desire was to build a client API for Spark that gives you the ability to leverage all of the power in the ecosystem of Spark, because remember, one of the key points why Spark is so successful is not necessarily because it's the fastest thing in the world, but because everybody contributes to it. There are so many different packages, from machine learning to data processing, file formats, everything that works with Spark. So if you want to bring in some data into your application, it's very likely that Spark has a way to consume this data, integrate with it, and so on. And that's why, it's so important to have this kind of connectivity interface. So how does this application, this connectivity layer work? So when we started looking at the problem, what we realized is that, and you're all familiar with this, is the DataFrame API resembles like general concepts of relational algebra. You could say, well, is it really? But at the end of the day, it's very easy. So for example, on the top, you find like some simple Spark code that says, okay, I want to read from a table, I want to project a particular attribute, I want to run a function on top of it, and then I want to insert this into a table, And this kind of code, this is very standard data frame operations. You find this in pandas, you find this like in all of these other implementations. And what we're doing is we're saying, okay, instead of trying to reason about this kind of logic directly already on the client, so this is what Spark does today, I want to basically transform this into a logical representation of the work and send this over the wire. You could say, well, but isn't that like generating a SQL string from a data frame? And the answer is yes and no at the same time. Yes, it's very similar in the way that you're creating a representation of your operation in a declarative way. No, because in a SQL string, like you don't have the same composability of operations. So in the data frames, like one of the things where again, like I come from traditional database systems building SQL databases. Like one thing I learned to love is this kind of like, I can build a data frame and then I can build another data frame on top of it and then I have another one and I can use them, compare them and interact with them. And this is very easy to reason about. Like trying to do that in SQL is really hard because now you have a SQL string, then you create another common table expression. Now you're trying to figure out like how do you join this with another common table expression. And all of a sudden you have a 2-page SQL statement and nobody knows anymore how to use this. And the other part is that there are a bunch of operations in Spark that aren't even representable in SQL. So there are a number of functions that, can be expressed on a declarative level, but they don't have an equivalent in SQL yet, or there's like some overlap. So, okay, so now we have this kind of logical path plan, and now we're sending this over gRPC to the server. And here our goal was like bringing Spark really into the 21st century because, again, until now there is no real Spark API. People that have used Spark Magic before know that's Livy as a project. And what Livy does is essentially it says, okay, give me your Python code, I run it as a blob on the other side, and it will give you a text back of the standard output of the thing that has happened on the other side. Which is kind of annoying because you lose a lot of the interactivity of this overall approach. So in our case, we send over the gRPC, the protobuf messages of the gRPC over gRPC to the server. It processes in the same Spark way and returns the results back as arrow, and then you can simply consume this on the client. All right, so Spark 3.4 was released about 3 weeks ago, and Spark Connect is now kind of a major part of the Spark open source project. So what is supported right now is, and again, like the project or the sub-project of Spark is roughly a year old by this point in time, is that most of the Python APIs are supported. So everything that you're doing right now with the PySpark APIs in terms of like data frames, pandas operations, filters, aggregations, all of this works. So we are currently in the process of building the Scala support as well. So if you are, for whatever reason, using Scala, there's a basic APIs are already available for Scala as well. However, there are some limitations because not everything is that great. When you think about this, in Spark, there are a lot of choices for different things. It's a very common problem of open source projects is that over time you add a feature and you add another feature, and it's kind of like hard to deprecate things because there might be this other person that still uses it. And and one of these challenges is, for example, how do we actually read data? So Spark has RDDs, it has data sets, typed data sets, and it has data frames, which are untyped data sets. And now, which one of those are we going to support? In our world, we're saying, hey, we want to support the declarative APIs, which is the dataset data frame APIs, and we don't want to support the RDD APIs. RDDs are still available in your system, so especially in machine learning, folks have been using RDDs a lot. They are still available, but you can't call them in such an easy way from the client. You need a translation layer into a data frame. The other thing, the Spark context as this kind of application concept in Spark isn't directly available on the client. And if for whatever reason you really like to enjoy manipulating the JVM using Python, you can't do this. The client is Python only, it doesn't have any Java dependency, and you can, so this means you don't have access directly to the driver JVM. So how does this actually look like? When you're creating a PySpark session today, everybody that has done this before knows the Spark session builder, get or create, and off you go. The one thing that we added here is essentially we added a new option to this called remote that allows you to specify the endpoint. The endpoint is in a way very similar to any kind of JDBC connection string that allows you to connect your remote host. And this is then just pointing to the remote endpoint and the port, you connect to it, and then you can run your Spark session from there. So as I said, Spark 3.4 is available right now. There's a bunch of documentation that we put online to users. In particular, for example, there is one quick start notebook that we put out there that you can directly try live in the browser, which uses MyBinder, which then uses some Docker images behind the scenes that allow you to play with Spark Connect directly from a notebook. And there's this one other question before I go into this and to the more Databricks side of things is, like what about Spark Magic? So Spark Magic, I mean, again, I use Jupyter, but I haven't used Spark Magic before. And I was looking into this and I was like, so why do I still need Spark Magic? So what Spark Magic offers you today is this kind of connectivity and configuration and authentication towards Livy and other systems that manage the Spark clusters for you. However, with Spark Connect, essentially, you don't need any kind of complex remote negotiation, Python process management anymore, because it's similar like connecting to a JDBC driver. You're just connecting to an endpoint. Your Python program runs locally. What this means is that if you want to debug your Spark program in Jupyter, like using the debug capabilities in the Jupyter notebook, you can do this. Your Python program is locally, but if you're running a blocking action on Spark, like collecting a data, executing something, then only then, Spark is actually connected to, and then the action is run. So I've been looking into like how can we extend Spark Magic, for example, to support Spark Connect directly. I think there's a bunch of opportunities to extend the project, or I was trying to reach out to the Livy folks, actually find a way to integrate Apache Livy with Spark Connect, because it makes their life significantly easier as well, and much more flexible. But Apache Livy is kind of in a zombie state. It's like between being used and not used. So there are a bunch of companies using it, but the open source contributions are kind of low at the moment. I think there are some efforts to resurrect it, but I don't know exactly what the point is. All right. The benefit of being a sponsor is I get some time to talk about like why it's so awesome to use Spark Connect directly with Databricks. And the cool part is, when we started this project, again, I switched from my open source head to my Databricks head, is that, for us, we want to make sure that people can use Spark from everywhere. As much as we love notebooks, like in my day-to-day life, I work with a bunch of software engineers, and they always say, notebooks are great, but, like I have my Ivy League degree from Harvard and Stanford, and I like to write unit tests. And I like to write modular software. I like Git. And don't make me use a notebook. Or I want to build an application. How do I use this? I want to define by myself where do I deploy my notebook service. I want to pick something totally different. Don't make these choices for me. And this is where Databricks Connect comes in, which is powered by Spark Connect, which allows you to basically connect from anywhere, from all of these different applications, platforms, languages, essentially, to the Databricks platform using Databricks Connect, which is essentially just a tiny wrapper around the Spark Connect protocol, making it easier to configure your endpoints, your warehouses, authentication, and OAuth, but essentially uses the same underlying concepts. What this means is that you can still use open source PySpark to connect to Databricks, but you have to do a little bit more handiwork. But like the protocol is fully compatible, and this is what we remain committed to, that Spark Connect as the underlying protocol, we will not block in any way, but we really embrace it, but we are just adding some additional features on top of it to make it easier to use. So again, like what we saw is that we have many customers that really like IDE-based development, and they want to continue doing this with Databricks. And so we've been giving them this Databricks, like we had a Databricks Connect v1, which is kind of like similar to Livy, trying to figure out like a way, like how do I submit some code that doesn't run locally but then pretends to run locally, and this was kind of complicated and was in maintenance mode for a couple of years. And now with Databricks Connect, the new version of it, what you get is this full access to Databricks governed lakehouse, the fine-grained access control, data lineage, and all of these kind of things, and you can use this from anywhere. The other benefit is that we have this Databricks VS Code extension, which makes it very easy to pick and choose your cluster, run on it, debug it, build a job, run a notebook locally, connect it to a cluster, and so on. So this is really making it much easier for our customers to work with our platform and giving them the choice of picking the tool that they like. To get started with Databricks, DB Connect is really easy. You pick a cluster that uses our most recent Databricks runtime. You pip install the Databricks Connect package, which is, if you've ever installed PySpark and you wondered why the hell is this downloading 300 megabytes, there are like 298 megabytes of jars in PySpark. And Databricks Connect is roughly 2 megabytes because it doesn't use these jars anymore. Like in case you're ever wondering, like, why is PySpark so big? And then you simply create a connection string which contains basically your workspace URL, your authentication token, and the cluster ID. and then you can run your Spark applications locally and develop and so on. So just skip this here. Just to give you an idea, so this is running on my MacBook, connecting to a cluster that is like fully remote. And this is, I connect to this and I have the full experience of like full interactive debugging from PyCharm here to my remote cluster, my remote Spark application. And like this is this kind of like this inner dev loop, as we're saying. This is what the folks really want, is this ability to have this high fidelity interaction with the code that they're writing, because even if you're writing test cases and everything, you always have the struggle of like, sometimes you just want to look at the data, you want to interact with this. And this is what Spark Connect and DB Connect in this case give us. And the great thing about this is this enables a whole range of completely new use cases that you can't really do with Spark today, which is, for example, like the integration with Plotly. So when you're using Plotly today, you either have to use SQL, or you try to figure out like, how do I run my Plotly application directly on the Spark cluster. With DB Connect and Spark Connect, you basically give it make it very easy to deploy your Plotly application wherever you want, and simply use the same Python and PySpark code that you're used to, but deploy it anywhere that you want, and simply connect to Databricks cluster. You have the debugging from IDEs, and this makes it very easy to integrate like with different partners with our platform, and build completely new use cases. Again, like just to give you an idea, like how does a Plotly integration look like, for example. So for example, this is, the first couple of red lines that you see there is really just the integration of like, how do I connect to my remote cluster? And then you just build the Plotly and Dash application the same way as you've been doing before, and now you can just deploy this wherever you want. And there's a public example on GitHub as well that you can use to get started, to just give you an idea how easy it is to really get started. I talked about partner integration already. Oh, I had an awesome video here that is not here. Damn it. So I had this nice video of showing like, hey, how easy it is, like run your Jupyter notebook locally, connect to Spark, and then like pick any. So this happens when you're browsing Hacker News, and find like, oh, somebody wrote this awesome plugin for Jupyter Lab that gives you this Tableau-like experience. I think it's called, I have to figure out, it's a visualization. Everybody that's ever used Tableau knows this, like drag and drop, columns and rows and everything. And this was basically like, you give it a pandas data frame, and then it gives you this kind of visualization in your cell. And what I really liked about this was that, like this trial and error, because today the problem is like, the customers that I talk to, they always have this challenge that, okay, they have the cluster, but how do they experiment? How do they make it very easy for their data analysts, for their data scientists to work with the data in the way that they want, So because it's then, okay, now you need a cluster, you go to the web UI, you have to figure out the library to install, but what if it's not supported in Databricks, or it's hard to use? I want to use my own configuration. And so they don't really have this way. But now with Spark Connect, you actually say, you control the environment in which you're developing, or that you're presenting the data, that you're training with it, that you're using it. You have complete control over this. And the Databricks platform provides you the ability to access Spark in the way that is useful to you. So if you want to use machine learning, if you want to do inference, you can do this on the cluster in any way that you want, and simply connect your own applications to it. And your own applications can be anything, essentially. All right. This was the very brief version of my talk. And if you have any questions, we can use the last couple of minutes for questions. Thank you so much.
Thank you, Martin. Yes, indeed. We have time for some questions. Okay, question in the back. The first one in the back, don't forget to say your name. You can get PyLady stickers at the PyLady stand as an awesome prize.
Yeah, PyG Walker, exactly, yes. Yes, that's true. I had a video, I don't know, like this happens when you try to adjust your slides too quickly, you lose the funny videos.
There was a hand here.
I assume you can define UDFs on the Java and Python using Spark Connect.
Yes.
Are you planning to allow the same from other languages, like Go or...
So there is currently a very brave soul trying to write a Go client for Spark Connect, and there's another brave soul trying to do this in Rust. So we have, so they are starting some discussions on the Spark community to figure out what does this mean? You know, because so far it was very easy to just say like, yeah, you know, it's Scala or Python, and even the Python code is, you know, the integration is, well, interesting. And what does it mean like if you write a Go client? And I think there's no good answer yet. So I think what we're trying to position this at right now is to say the clients are mostly clients. So we're not trying to figure out like yet another way to run Spark submit like an arbitrary binary, but rather say if you have an application that is right now written in Go and you want to connect to it, go ahead, do it. And then if you need a UDF, we'll figure out a way over time. But this really depends on like, if there are a million people using it, it's much easier to convince this Apache Spark community to say, sure, let's go. But if it's like 3 people on their weekends, it's, you know, much, much less likely to happen. But, you know, there are people starting to work on this, and I really think this is one of the big changes to Spark, because being able to use Spark not just from, you know, like Scala or Python is going to be a big game changer, especially for application development. Maybe not so much on the interactive side, because Python is really great for that, but, you know, like application servers and so on, that's a slightly different story. Yeah. For the record. Yeah.
Hi, my name's Mark. I had a question about, to use your JDBC analogy, it seems like, you know, the database would already be set up, but I was wondering, is there work to support maybe Kubernetes as the cluster manager? Because sometimes in an interactive mode, you might not know how much resources you need, so something like that.
So I think this is exactly the delta between, you know, where I see what Livy should provide and what Spark should provide. So the ability, for example, to use the Spark cluster in Kubernetes mode, where you're saying I need a particular set of resources, and then it starts a Spark cluster, basically the driver node and the executors, and then you're just connecting to the Spark Connect service, which runs basically it started as a driver plugin on the driver. So driver plugin on the driver, yay. And so essentially, if you have a large Kubernetes cluster and you have a Kubernetes resource manager, you can start as many Spark clusters as you want, and then point your users to the individual, you know, drivers that then run the Spark Connect service. The key part here is that, and this is again like where Livy comes in theory, is that the routing between like a fixed DNS endpoint and the different drivers, this is what Livy should provide. So in what we have in our setup is we use an Envoy proxy in front of our clusters to route the traffic to the individual driver nodes. And I think this is, you know, it's HTTP2, it's very easy to do, there's no black magic involved, and that's the cool part about this. Any kind of enterprise solution that you have today that allows you to forward and proxy HTTP2 traffic will work. So and that's why, you know, like, once even all of this works in all of the deployment modes for Spark, so Kubernetes, you know, custom cluster, whatever, because as soon as you start the driver plugin, essentially you start the process and then you can connect to it.
Cool. We have time for one last question, if there's anybody.
I have Dolly stickers, like because I know like Databricks went through the news most recently for like Dolly, our fancy LLM model. I have stickers for that, you know, like these fancy sheeps. So in case of anyone, I can give those out.
That's really cool. Then, so for the question or in general?
No, just in general, because I'm a nice person, even though.
Cool. So thank you very much, Martin. And this concludes the morning session. Then the technicians can go for lunch. They kindly asked to be on time, so that's like awesome.
Yes.
And then everybody go get lunch and stickers, and you know where to find him.
Thank you.